Hi, everybody. Welcome to our next show again. We have a full panelist team today and some nice speakers waiting to give us some nice content and great information about specific stuff. First up, my name is Jeffrey. I will introduce you to the panelists. Bjorn, take it away.
Yo, well, glad to be back here for another Dutch Angular meetup.
And we have Sander today.
Hi.
Stepan is joining us.
I don't need an introduction. Everybody knows me, right?
Yeah, that's true. That's true. I know. Who doesn't know Sander, right? And we got Aris. He will give us a great talk about Electron. And Aris, are you ready to start off with your talk?
Yeah.
Right. Take it away if you can share your screen.
Sure.
Let's see, and it's here. Okay, Aris, the floor is yours.
Thank you. So, hello everyone. My name is Aristeidis Bampakos, but you can call me Aris because my name is difficult to pronounce if you are not a Greek. So today I'm going to talk about a very interesting topic and very unusual in the front-end web development world, which is how to build desktop applications using web technologies. And when we say web technologies, of course, we mean JavaScript, CSS, and HTML. Particularly, we will see how to integrate two awesome JavaScript frameworks, Angular and Electron, to create an awesome desktop application. So, let me tell you some things about me. I am a co-organizer in another meetup, which is held in Greece, and specifically in Athens. I stay in Greece. So the meetup is called Angular Athens Meetup, and I work as a front-end web developer at Plexearth team. I also work as a contractor in a private educational institute called Code Hub, where we teach the Angular framework to other individuals and developers. I'm also an active contributor at GitHub, where my main focus areas are Angular-based repositories. I'm an occasional contributor to the Angular docs. And I'm also very interested in projects that are related with 3D maps or geospatial libraries. When I'm not coding, I maintain my blog at Medium, where I mostly always write about Angular. And also, this month, I completed to write my first book in Angular called Learning Angular 10. It will be available from next week for sale. It's now in pre-ordering. It is available in Amazon and PactPub. This book is destined for Angular beginners. It guides you through scaffolding. It guides you through using the Angular CLI to create an Angular application from scratch up to deploy it to a hosting provider. So, as I told you, I'm a front-end web developer at Plexearth. Plexearth is a main product of a company called Xstate. It is the first ever created cloud-based software that was created for the architectural, engineering, and construction industry. It works with mostly all known CAD software. For those that don't know, CAD software is software that is used from architects and civil engineers to create buildings, houses, and stuff like that. Construction, mostly. So Plexearth is a plugin that can integrate with all this CAD software. The mostly well-known integration of Plexearth is with the AutoCAD software, which is what you see in this image. You can see that Plexearth is a ribbon that has some commands that the user can execute. Now, the main features of Plex Earth are three. The first one is that we can import satellite images inside CAD software. The second one is that we can import actual terrain images inside the CAD. And the third one is that we can export from a CAD software the 3D model of a user into Google Earth. So you can understand that Plex Earth enables architects and civil engineers to visualize their projects in the real world. So today we're going to talk about the import imagery feature. Plex Earth can import satellite images in three different ways. The first one is using some core providers like Digital Globe or Hexagon. These providers have their own satellites or small aeroplanes, and they can take their own satellite images. The second one is using an intermediate provider, such as Google Maps or Bing Maps. These providers usually don't have their own satellites, but mostly they use some core providers to buy their satellite images. And the third way is using a proprietary custom software that we have created at Plex Earth, which is called Map Explorer. To get you let me now explain to you a bit more about how we think of a map in terms of Plex Earth. We can think of it as a set of different layers. For example, if you want to create a map that displays the United States of America and different background color for each one, you would use three layers. On the bottom, which is called the base layer, you would put a layer that covers all the world, all the globe, for example, Google Maps or Bing Maps. On top of that, we would put another layer, which will cover only the United States of America that we want to visualize, with different background color for each layer. So you can think of it as when you put slides on a projector to display something on a remote screen. I will now show you a video that we have created to see how we use Map Explorer inside Plex Earth to import images into AutoCAD. So this is, now you can see the environment of AutoCAD. We use Plex Earth, the ribbon, to open Map Explorer. Now, this application is Map Explorer, okay? It has already a base layer, which is OpenStreetMaps. So we will put another layer on top of it, which is called ESRI. ESRI is a very well-known map provider, like Google Maps. Okay, we put the layer, and now we add a different layer, which is the final layer that we want to import into our AutoCAD project, which will indicate the railway network of a city. Now, all this interaction is made with Angular, Electron, and the user interface has been created with Angular material. Map Explorer is a different executable file. Okay, so here it is. We created the third layer, which is only the blue lines. Okay, the third layer is only the blue lines. So we overlay it on top of the other layers. We can switch, we can toggle the visibility of some of the layers. Now we close up Map Explorer and we go back to AutoCAD, where we select the area that we want to import our map. So now Plex Earth starts downloading the map that we created with Map Explorer. And here it is. Let me switch to the slides. Okay, so Map Explorer is a different application from PlexEarth. Okay, so PlexEarth opens Map Explorer, does its job, and closes. Now, Map Explorer, as you can see in this image, is created with Angular and Electron. It is actually an Angular application that is packaged as a desktop application using Electron. So, we all know about Angular, I think so. So let's see what is Electron actually. Electron is a cross-platform JavaScript framework that allows you to create desktop applications using web technologies. It is actually an NPM package, so you can install it with the usual command npm install. Now, we install it in the development dependencies of package.json, if you see here with the -d switch, because Electron is not used finally in our application, but is only used, it is not used runtime, it is only used to build our application. Now, the main advantage of an Electron application is that a web developer can leverage their existing skills to create desktop applications without the need to learn a new desktop language, such as C++ or C#. Now, Electron is built on top of Chromium, Node.js, and the V8 engine from Chrome. That is and also the executable of Electron applications is very large because it contains a version of Chromium and Node.js embedded inside. For example, imagine that Map Explorer is about a total of 98 megabytes, and 97 megabytes are only, the 93 megabytes are only the Electron runtime. Our application is only 3 megabytes large. This is a major drawback of Electron applications. Now, many popular applications have been built with Electron, such as Visual Studio Code, that I think most of us use nowadays, or Slack and Skype. In their website, they have a very extended long list that displays all the applications that are built with Electron. And believe me, you will may see applications that you don't imagine that they are built with Electron. Now, let's talk a little about the architecture of an Electron application. It has two processes. The main process is responsible to make some heavy tasks and calculations, for example, to interact with the file system. And it is this process that provides access to native resources of the machine using Node.js API. Okay. And the renderer process is responsible for managing only the user interface. So in our case, the renderer process would display the Angular application. Imagine that it is only an index.html file that loads your application assets. Now, because Electron follows the multiprocess architecture of Chromium, one Electron application can have only one main process, which can communicate with different renderer processes. But please notice that each renderer operates in complete isolation. There is a way to communicate one with the other, but it is advisable to communicate via the main process, as we will see later. So, let me switch to the code to show you how we create an Electron application. So here, we're in the environment of Visual Studio Code. This is part of the application that I will show you later on. So, how do we create an Electron application? First of all, we use the Electron npm package to import two basic objects: the app, which is the Electron application object, the global object. Imagine that it's like the window object of a browser. And then we use the browser window, which is the window that we see on a desktop application. Then we have a function which is called createWindow, which creates the actual desktop window, we use the browser window class to create a new instance of browser window, and we set some properties, width and height, to set the size of the window. Now, browser window takes a lot of other settings that you can check in the website. But the most usual ones, these that are needed, are width and height. Then we use the load file method of the main window, and we pass the the HTML file that we want to load inside Electron. Now, in our case, and we will see later how it is accomplished, this index.html file is the main HTML file of the Angular application. Then we call the whenReady method of the app object, and this is a promise. When it is resolved, then we create the window. We create the window in such a way because we want to be sure that the application will be ready so that we can create the window. As far as I know, you can create multiple windows in a single app object. I haven't done it so far, but I know that it is viable. Excuse me. So, Map Explorer has three main characteristics. The first one, actually, let me tell you a little story. Map Explorer was always part of PlexEarth, but it was embedded inside the PlexEarth. Okay, so we decided to rewrite it from scratch and create it as a standalone desktop application because we wanted to enable collaboration between different users and environments. For example, imagine that you are a civil engineer, that you sit in front of your desk in your office, and you use AutoCAD to create a 3D object, a 3D model, a building. So you want to use a map. What do? You open Map Explorer, which is a desktop application. You select the map and you download it, as we saw in the video previously. Now, this map could have been created from another user, maybe an administrator, that he would logged in a web interface of Map Explorer. So we wanted the code base to be somewhat independent of PlexEarth. Now, for us, for PlexEarth, Map Explorer, we tend to say that it is serverless. And when we say serverless, we mean that our backend API, our backend is Electron, and our frontend is Angular. Okay, Map Explorer downloads images. So imagine that the Angular application, the Angular part, gets the image and gives it to the backend, which is Electron, and Electron does his thing. Okay, so we don't just render a web application inside the desktop window, we do more than this. Also, a very interesting challenge that we faced when we started to write it from scratch was how to communicate between the two different, Map Explorer and PlexEarth, because I told you that there are different separate executable applications. So there is no easy way to do this. I will not go too much into detail about that, but if anyone is interested, I'm happy to give more details. So, I told you already that we have the main and the render process in an Electron application. How do we communicate between each other? We can use an object which is called the remote object. The remote object is an object that is exposed from the main process, and it has a global property, as we can see here. Now, in this global property, the main process can attach different variables, global variables. Okay, I told you before that you can think of the global as the window of in a browser. Okay, so for example, the main process could expose inside this global object the FS library. The FS library is used, for those that do not know, for interacting with the file system. So when the main process has exposed this FS library into the global, the renderer process can import Electron API and use the remote object to get this global. Okay, so I'm actually telling you that you can export your file system into a web browser. Who wants to do this? I mean, it's very insecure. It has a lot of security considerations, okay? Because we should not forget that an Electron application is like an ordinary web page. Whatever security problems you have in a web page, you have it in an Electron application. So you need to be proactive when we talk about security. So we don't do this. And if you do this in one of your projects, you should disable it. How do you disable it? You can pass inside the browser window constructor that we saw earlier, inside the web preferences object, a flag enable remote module and set it to false. So even if the main process exposes global variables in it, the renderer will not be able to access it with this flag. Okay, so alternatively, what we can do? I mean, okay, remote is harmful. I have also put a link in the end of the slides that explains in a Medium article why it is harmful. So Aris, what can we do? Okay, sorry, this one. We can use the Ipc communication object, the Ipc communication technique. So the Ipc communication is a technique for exchanging messages between the main process and the renderer asynchronously. Okay, so in the main process, there is an object called Ipc main, which we can import from Electron. The Ipc main has a method handle that functions a bit like adding an event handler. Okay, so you can add an event handler and pass it a name to identify this event, for example, get data, and then an arrow function that will be executed when someone calls this get data event. Okay. Now, how can we use this event in the render process? Again, we can import the Electron API with require, and it has a similar object, similar to the Ipc main, which is called Ipc renderer. We can use the method invoke of the renderer to call this event. So we pass the name of the event that we want to call. If we want to pass any arbitrary data and send them to the event, we can use the second parameter of the invoke method. Now, please notice that here we use async await syntax because it is supported in Electron, and the Ipc communication is promise-based, so we can use it as all. We can use it normally. Now, I told you before that the remote object has many security considerations, and generally Electron has security issues. Recently, I made a talk in the Real Talk JavaScript podcast where I talked specifically about what security problems exist in a desktop application and how you can handle them. Okay, so if you wanted to check it out, I have put the links on the slide. Okay, so let's see some code now. Okay. Okay, here I have created an Angular application, simple Angular application, using Angular CLI. If you see here, maybe the structure is familiar for you. because I have created with Angular CLI, obviously. It has only one component, and let's run it. To run it, I use an extension of Visual Studio Code called NX Console. I find it pretty good if you want to use it with your Angular app. I mean, it fits better to my needs, so I think it's okay. It is created from the Narwhal team. So here you can run some basic commands from the Angular CLI, such as serve. You select your project, and then you can pass additional properties, just like you would pass it from the command line. Now I want to leave only the defaults. So if I click run, it builds my Electron application.
It always takes a while the first time, eh?
Let's pray.
The first time that you run
let's pray that the demo got the good.
Yeah, exactly.
Okay,
it's
if
fine,
I now
it's
open
fine.
in the browser, okay. You can see that the layout looks like an Angular CLI application, the skeleton application that the Angular CLI creates by default. I have leave most of the code and the styles, but I have added here some pirate names. I chose pirate because I'm a fan of Assassin's Creed Black Flag, which I have behind me. So this is where I took the idea. So you can see we have some pirate names. Okay, let's see how we can compile this application as an Electron. Okay, if we go to the package.json, now let's go first to the code. Okay, inside the source folder, I have two folders, one for each application. The app folder contains Angular specific code. The Electron folder contains Electron specific code. So if I open the main.ts, main.ts, it's the file that I showed you before, is a main entry point of an Electron application. It's just like the main.ts of an Angular application. Okay, you can write it in JavaScript, but I prefer TypeScript because my stack, which is Angular, is TypeScript, so I want to be consistent. So you can see here it's the create window that we used before, index.html, and the create window, and some other stuff that I will not go through them now. Okay. So here it says index.html. Now, this whole Angular application, desktop application, okay, to say, it consists of the Angular part and the Electron part. All of these are built and outputted into the same directory. Okay, we build the Angular application as we do with ngbuild normally, and it outputs the files in a dist folder, and then we use Webpack compilation, a Webpack custom configuration to compile this main.ts file and put it inside the same folder, inside the same dist folder. Okay, and we do this because we want the Electron part to can load the index.html. Let's see how it works. I will now delete the dist. Okay, inside package.json, I have created a script which is called start Electron. Now this script builds the Electron and the Angular code simultaneously. I use the concurrently npm package. First, I build the Angular application, and I pass a specific Electron configuration, a specific Electron environment, and also I build it without deleting the output path, because in the same output path, we will put the Electron code, the Electron output, okay? And then we also compile, we also start Webpack with a custom Webpack configuration that we have created with a watch mode. Let's see that. If we go to npm scripts, okay. Now it starts executing. First, it will build the Electron. I think so, because it's smaller. Yeah, this is the Electron. This is the cell.js is the Electron code. I'm sorry. And now it starts to compile the Angular part, the Angular code. Come on, you can do this. Okay, so it finished. Now, if I go to debug, I have created a specific debug configuration for Electron. It's like it's the same configuration when we create a Node.js application. I have put the configuration inside the launch.json if you want to check it out later from the repository. So if I press start, shit, somebody bad happened. Why?
It's not a live demo if something doesn't go wrong.
Yeah, always.
It always has to be something.
Let's go again. Why? Let me see. Let's go to the main.ts. Don't see anything bad here. Let me make an npm install. Maybe he wants to refresh the npm registry.
I think in a glimpse I caught there of that exception, it said that the import statement was incorrect.
Yeah, but
might be.
It doesn't look to be incorrect.
No, fair.
Why is this?
Cannot use import statement outside of a module. Is that a TypeScript tsconfig type of thing? Perhaps?
I haven't anything else from. Let me make a pool. Maybe it has something changed. Let's see.
Okay, so Bjorn even got a question, and now it's building. We can even ask it in between, right?
Yeah, where that might be a good idea. Like, so you...
Yeah.
I can put it on the
so
screen.
You were showing us about the... you were talking about the Webpack configuration that you custom built for Electron. In order to get to that situation, did you have to eject the original CLI, build Webpack configurations, and create a new one? Or how did you get to that point?
Yeah, the Map Explorer was built when there was Angular CLI, an old version that allowed you to eject the configuration. So when we started it then, we had injected the Angular CLI configuration. And we took the Webpack configuration and just removing code that we didn't need, and we were left with what it worked actually. I mean, we didn't inject. We didn't inject something.
No, you basically brought this project over from an older version. That's yeah, exactly. I understand. Thank you. That answers my questions.
No, it doesn't want. Don't know why. Let me make a build, a production build, to show the Electron part.
Sure.
Okay. Because except from here in scripts, we have start Electron and we have also build Electron. Now, build Electron is when you want to create a build for production, which again uses the ng-build command with some production specific parameters. And then it uses again the Webpack, but with a different configuration. Here, if you see on the Solution Explorer, we have two different configurations for Electron, one dev, one prod. Each one relates with a different command here. Okay, it was built. Now let me package it. Except of building it, I also package it using a library called Electron Packager, which it actually takes my code and packages it as an executable. Okay. So if I go here, if we go to the dist folder, here is the dist, here is the packaged application, okay? The Electron Packager that I used supports the three major operating systems, Windows, Mac, and Linux. So you can build for whatever operating system you want. Now here, we can see the executable, which is contains the runtime of Electron. And if you see here, it is 105 megabytes. Here it is. Only the runtime executable of Electron. Our code is not inside this executable file. It's inside the resources folder, this app.asr file. Asr is a zip format, especially for Electron applications. You can open it with any zip client. Okay, and you can see here that it is only 188 kilobytes. I mean, that's impressive. Let me try to run it. Okay, cool. So this is the desktop application. We're actually rendering an Angular application inside a Chromium window. Now this window has Chromium inside. If we go to Toggle Developer Tools, you can see that we have console, we have elements, we can inspect, just like we would do with a web application. Now, I want to show you also here, if we go to the dist folder, okay, here it is the dist folder that is created by building the Angular code and the Electron code. You can see here that it has a main.something has.js. This JavaScript file is the Angular code, and this one is the Electron code. Now, if you remember here, we told that we want to load file index.html. So the main.js and the index.html are on the same path. So they can be loaded normally. You don't have any problems with paths and stuff like that. Even when this distributor, even when this folder goes inside the app.asr file, again, you can have the index.html can be found easily from the Electron code. Now, I want to show you something as a last tip. The application that I showed you before in the browser was displaying the pirate names from a file called pirates.json using the HTTP client. Okay. Now, the Electron, the desktop mode of the applications that you saw, it doesn't use HTTP client to load this file, but it goes through the Node.js, through the main process. The main process reads the pirates.json from the file system and gives it to Angular. So there is no HTTP call involved in this situation. And how do we do this? We have created here inside the app folder, we have two services. The first one uses the HTTP client to get this pirates.json file, and it returns a promise. That is why we use the toPromise ArcJS operator, because we want to use async await in our component. If we go to our component, you can see the getPirates method uses async await to call the getPirates method of the service. Now, we have also created a Pirates local service, which uses the Electron service. This service is used from a package called ngx Electron, which is a wrapper library for Electron. And here you can see that we use the renderer to invoke the getPirates to the main process. Okay, so this invoke goes to the Electron code, goes inside main.ds, and here we have created our event handler with the same name, getPirates, and uses the fs library to read the pirates.json from the file system. So no HTTP call. This is actually the method that we use in Map Explorer for exchanging images, okay, satellite images back and forth. I have put this this repository in my GitHub profile. If we go to here, this is the last slide. I have put my communication details on the left-hand side, and on the right-hand side, I have this the repository that I show you the code and some additional stuff. So that's it. Thanks very much. I hope you will find it interesting, and that you can start creating Electron applications, desktop hybrid Electron and Angular applications from tomorrow.
Well, thank you
so much.
Yeah, thank you, Aris. It was a great talk.
I would like also to thank personally Stepan, which is co-hosting this meetup, for helping me with these slides.
Little virtual applause for Stepan as well.
So, has anybody have any questions? Because I see we don't have any questions at this moment for the audience.
I have another one, if you'll indulge me, because you showed that you had two different services, but like at which spot? I mean, I guess I could go into your repository, but maybe it's fun to quickly talk about it. Like, how does the Angular part of the application switch between these two services? Is that environment based? How do you do that in your specific example?
Yeah, good question. I omit to show you this part. If we go to the environments, where is it? In the environments, we have the usual environment.ts and environment.prod.ts, but we have also another one, electron.ts. Now, this one has an additional property called desktop, and this is true. So we can use the powerful Angular dependency injection mechanism, and inside the app.module, we can actually replace, according to this environment, which service we will create. For example, here in providers, we use the provide object literal syntax to say that if someone asks for the pirate service, use a factory and add some dependencies that you will need. Okay. If I go now to the pirate factory, you see that it checks what is the environment that we are building? Is it desktop? No. So we create a pirate service with HTTP injected. Are we in desktop now? Yes. So we create a pirate local service and we inject the Electron.
I see. Very cool. Very nice. Thank you.
Okay, we got another question. It's from Stepan for Sander, I think, something like that. Why would we prefer Electron over desktop PWA?
If you want to just render a web application as a desktop, you can go with PWAs, because nowadays a progressive web app is very powerful. I mean, it has many features. But if you want to do some custom, if you have some custom logic, like we did with image processing and the image satellite image handling, then it is better to go with progression. Now, the main advantage of PWA over desktop is that the desktop, as you saw, it's very large. It may go up to 100 megabytes, and 90 megabytes will be only the runtime of Electron. So if you have also size considerations in your application, you can go with a progressive web app. For example, in our case, in PlexEarth, PlexEarth is a desktop application. Okay, it has built with Microsoft services. So when we release a new version, we bundle the Map Explorer, and we don't have any problem. You can download it and get the application.
Okay, great. Hope that was an answer on the question. Okay, then thank you, Aris, again, and we can continue with Stefanos. So let us share your screen.
So, can I hear me? Yes.
There it is.
Okay. Awesome. Have fun.
Okay. Thank you. So, hi guys. I would like to thank the Angular group for having me here today and for organizing this event. So today we're going to talk about how we can work with state machines in Angular. But first things first, the agenda. So why do we have this presentation today? Why I started investigating this topic? Why I started reading about state machines? Then we're going to see what is a finite state machine, what is a state chart, what is Xstate, how we can create and use state machines in Angular, when it would be nice to use them, and some takeaway notes. So this is me 3 years ago. Back then I was working in Greece in a big enterprise application. And after 1 year or something, I started wondering what makes our software so complex. And initially, I have a very abstract thought about this. I said, okay, it's not our fault. It's not something that we can improve. It's not something that we can change. It's something like a law. The more modifications that you do in your code base, the more people that you add in a project, then the more complexity you get. And I was okay with this excuse, basically, for a while. But then I started reading a paper from Ben Mosley and Peter Marks. The title of this paper is Out of the Tar Pit. And what they try to do on this paper is that they try to explain what is the complexity of a system and what are the factors that increase the complexity on a system. And what they say actually is that we say that a system, or to make it more explicit, that a code base is complex when we struggle to understand it. Because what we try to do most of the time as developers is to read the source code. We try to reason about the source code because probably we want to add a new feature or we want to extend a current feature. So When it comes to understanding of the code base, there are two factors that impact it drastically, the state and the control. So when we say state, we mean all the different representations that our system can have at a specific point in time. And what we try to do most of the times is to identify and keep track of all these different states. And actually what we try to do, unfortunately, is that we try to understand how our system works instead of what is the intended behavior of our system. And then you have the control or the order that things happen in your code base. And when this is the moment that we act like virtual compilers, actually, and we try to understand what is the flow in our code base. And the mental effort that we have to put in order to understand the state and the control increases as long as the complexity of our code base increases. So I had all these things on my mind. From the abstract notion of software entropy, I had some more concrete reasons for the complexity in our software. And then, one day on my GitHub recommendations, I found this library. It's called Xstate. So I started reading about this library, and what you can do with this library is that you can create finite state machines and staters in your front-end projects. One thing that I forgot to mention in the previous slide is that we talk generally about complexity in our code base, but also there is another kind of complexity, the complexity of your development process. And generally, what we want to have in a team is that we want all the participants to be able to speak the same language. So we want the business analysts, the QA team, the developers to be able to speak the same language. So as I said, I found this library. I knew from my university that what a finite state machine is. And for me, that moment was one of the few moments that you have, and when you realize that you might have something really nice in front of you. So it was like a light bulb moment for me, because I realized that if I would use the state machines in my front-end projects, I would be able to solve the two major problems about the complexity that I mentioned earlier. So I would be able to reduce the mental effort that I have to put in order to understand the state and the control in my code base. And also, I would have a common language for all the embedders in my team, because everybody can understand and read a diagram. So this is my journey to state machines, and this is me. My name is Stefanos Lignos. I'm a front-end developer in a company called LexisNexis. You can find some information about me on my GitHub account, in my Twitter account. I'm not always dressed like this, but an ex-colleague of mine created this this photo that I said to him that I'm gonna use it in one of my presentations. I'm the co-organizer of the Angular Athens meetup. We created this meetup in 2017 with Katerina Skrubelu, and after a while, Aris joined our team as well, and now we have a very good team. And since our meetups now are online, you can participate if you want. So, what is Xstate? What is a finite state machine? And what is a state chart? A small disclaimer here that this is not a detailed explanation about Xstate. I don't believe that you can teach, and I wouldn't like to teach a library through a presentation. Probably there are people that they can do it better than me. My intention is just to inspire you, just to motivate you to search about something that I believe that it would be helpful for your application. So Xstate is a library for creating finite state machines and state charts. It is created by David Kurside. You can find him on Twitter with the David K. Piano username. But what is a finite state machine? In order to explain what a finite state machine is, I will give an example. I will give, as an example, the life of a programmer. So as we all know, developers cannot do a lot of things during the day. They can sleep, they can write some code. And let's say that our developer initially is in a sleeping state. Then when an event occurs, like the alarm clock, for example, she transitions to the implementing feature state. And then she can push the code and go back to the sleeping state. Or if there is a bug found event, he transitions to the solving bug state. And then when the bug is fixed, he transitions to the implementing feature state. Or she can push the code and go and transition to the sleeping state. So a finite state machine, as we can see here, is nothing more than a directed graph with a finite number of states. We have an initial state and some transitions which are based on some events. The important thing to mention here is that on the finite state machines, we can be in only one state at any given time. And then we have the state charts. A small history about state charts. David Harrell invented state charts in 1982. Back then, he was working for the Israel aircraft industries. Actually, what they were trying to do back then was to create a fighter aircraft, and they had some teams of brilliant engineers, but they had some problems with the productivity. So they asked David Harrell to work with them. He started working with them once per week, and after some weeks, he realized that the main problem that they had was that those brilliant engineers, they were not able to communicate in a proper way the things that they had in their minds. So he created the language of state charts in order to help them to express what they had in their minds. So a state chart is a finite state machine extended with the notion of orthogonality and a hierarchy. So if we go back to the example with the life of a programmer as a finite state machine, we can see that we have from the solving bug state and the implementing feature state, two transitions based on the same event, based on the push code event. What we could do instead would be to write the state machine like this. So here you have a parent state, which is the coding state, and then you have two nested states, the solving bug state and the add future state. So when you do this, you can have only one transition for the push code event back to the sleeping state. So what we did here was that we reduced the number of transitions, and here it might seem trivial, but on big projects with state machines that they have a huge amount of states, it's very important for your state machines to be readable. For the same reason, we have David Harrell introduced the notion of orthogonality. So imagine that we have a second developer who works in parallel with the first developer, and he can be in a refactoring state or in supporting either an Explorer 11 state. At this moment, we can observe 1 minute of silence for this developer. Life is not always fair. So what we try to do here with the orthogonality is that we try to express all the different combination of states that we can have here with these developers that work in parallel. So with states, you can also have guarding transitions. So for example, you cannot transition to a state if a condition is not fulfilled. You can have history nodes. That means that the second time that you visit, that you start a state machine, you start from the previously visited state, delayed event and transitions, and so on and so forth. Okay, so we have seen what is a state machine, what is a state chart, what is Xstate. So let's see now how we can create and use them with Angular. In order to do that, I have prepared a demo. So this demo is based on the GoThinkster real-world application. So on this project, what they try to do is to create the same web application based on different technologies, both from the front end and the back end. So you can find the same web application with implemented with Angular, with React, with Angular and NGRX, and the same for the backend. What I'm trying to do, what I did basically for this demo is that I created the authentication process for this web application. And you can find the code later if you want under this repository on my GitHub account. So for the authentication process, we want to create a state machine, as I said. So the first step that we have to do in order to create this state machine is that we want to define the states. So we need an unauthorized state, a sign-in state. This is the state that we are when we do an API request, when we in order to log in or to sign up. We have an authorized state and an updating state. So after this step, if we do this, if we write this configuration, what we get in the visualization tool, which comes together with Xstate, is something very simple. We get just some 5 states, basically. So this is not enough, of course. We want to have some transition between these states. In order to add the transitions, we have to define the events. So, for example, when you are on the unauthorized state, on a sign-in event, you transition to the sign-in state. When you are on the sign-up state, on the unauthorized state again, on a sign-up event, you transition to the sign-up state. And also, for example, when you are authorized and you have a logout event, then you transition to the unauthorized state. So after this step, what we get in the visualization tool is something like this, is the states, but now we also have the transitions between these states. But in real-world applications, this is not enough, of course, because we want somehow to express the side effects in our application, like an API request for the sign-in, or we want to save something in the local storage. So the nice thing with state charts is that the side effects are part of the configuration of the state machine. And I'm saying that this is a nice thing because, for example, on the Redux design pattern, the side effects are not part of the pattern, of the Redux pattern. You need to have third-party tools. So here, what we do is that on the sign-in state, when we are in the sign-in state, we invoke an observable, the sign-in observable, and on the implementation of this side effect, the thing that we do is an API request which returns back a sign-in success event if the request is successful, or a sign-in fail event with some errors if the request is failed. All right, so let's go back to the example with the life for programmer as a state chart. Here you have a finite number of states, as we said, but also you might want to store somehow or to express somehow the potentially infinite data that you might have. For example, you might want to store somewhere the potentially infinite number of bugs for Internet Explorer 11. So you do this with something that we call extended state or context. In our state machine for the authentication process, we want somehow to save the user data in case the API request is successful, or the errors in case we, I don't know, the user entered wrong credentials or something similar. So we have defined our context, and then we want somehow to assign the data that we get from we need to assign the data that we get from the API request to the context. We do this with something that we call fire and forget effects or actions. So on state charts, you have two types of side effects. You have invoked side effects, invoked effects, like the one that we saw earlier. These effects return an event back to the state machine, or they can receive events. And also, you have fire and forget effects, as I said, and they don't return anything back to the state machine. They just do a job, and this is it. So here we have the assign user action, and its job is to assign the user data that we get back from the server to the user context. The same thing we do for the errors. And of course, you can have this kind of actions when you enter a state or when you exit a state. So after this step, the visualization that we have for our state machine is something like this. Initially, we are in the unauthorized state. And then when we have a sign-in event, we transition to the sign-in state. And if the sign-in is successful, we are authorized. And then if we have a logout event, we transition to the unauthorized state. And also, for example, if you have a sign-in failure event, you are unauthorized. So at this point, what you can do is that you can go back to your business analyst, and you can say, okay, I haven't implemented anything yet, but this is what you're going to get at the end. This is the how the authentication process will work. So do you want me to change something? Are you happy with this process? So what I'm trying to say here is that one of the benefits that you have, that you get when you work like this, is that you reduce the back and forth communication between the developers and the business analysts, for example. All right, so we have defined the configuration for the authentication process. Now let's see how we can use actually Xstate with Angular. I would say that it's quite easy to start using Xstate in Angular. However, I think that there are not enough examples out there, and there is not a common pattern. And in Angular community, we love patterns. And also, there are no helper functions to create a state machine, like, for example, in React or in Vue or Svetel. And maybe these are some of the reasons why Xstate hasn't been adopted yet from the Angular community. So let's see how we can use it in an Angular project. So the steps that we have to make is that initially you have to pass as an argument the configuration that we've created earlier to the machine factory method, and then you get a stateless enriched version of the state machine configuration, and then we have to pass as an argument this machine to an interpreter, and the interpreter returns back an observable-like object, where we can so from this object we can create an observable, and in our components we can subscribe to it, and we can start listening to changes to our state machine. But okay, this is quite easy to do this thing. It's not so many steps, but generally in a big project, we might have more requirements. For example, we might want to persist the current state of the state machine for every transition to the local storage or to the session storage. We might want, when we refresh the page, to start the machine from a specific state. And also we might have a lot of state machines in our project, and we don't want to repeat ourselves. So what I did on this demo project is that I created a helper function, the use machine function, which takes two parameters, two arguments, the machine and some options. So from the options, we can say that, for example, I want to start this machine from a specific state instead, or you can say that from the options again, you can say that I want to persist every new state to the local storage, or not. And then what you have to do in your service, for example, is that you can say auth machine equals use machine and your configuration and the options that you want to pass, and then you can start using the machine for the authentication process. So this is how you can use Xstate with Angular. As I said, there are methods like this, like the use machine function that I have here. There are similar methods for React, for Svetel, I think, and for Vue on the Xstate library already implemented. For Angular, there is not something yet. I will try in the future to provide something similar implementation. Okay, so we have seen how we can use, how we can create and use state machines in Angular. Let's see when it would be nice to use the state machines and Xstate in our projects. So, of course, you don't have to do this. I mean, we were able to build web applications even before Xstate. However, you can ask yourself, is the business logic of your application embedded, or a specific feature embedded, spread across your components and your templates? With Xstate, you can have one source of truth for the business logic, for the behavior. It's framework agnostic, so the backbone, the business logic of your application can be migrated immediately to another framework. And we all know how expensive a migration can be, even from AngularJS to Angular, for example. business logic and the behavior is decoupled from the components, so it's easier to be tested, and also the components, it's easier to be tested. You increase the readability, and also it's easier to extend the current functionality for the same reason, because you don't have to search in 5 different components in order to make a change. You can also ask yourself, do I have a common language in my team? Do I need documentation for the business logic? So with Xstate, everyone can understand the visualization of the state machines. So you can have a common language for your team. You have less back and forth communication between the business analysts and the developers or the QA team. And also, when you create a state machine, automatically you create a documentation for this particular feature. And the last question, is my code base unpredictable and buggy? The nicest things, in my opinion, when you start implementing features based on state machines, is that it forces you to think about solution of a problem up front. And also, you can prevent some edge cases because through the diagram, and not only through the diagram, through your configuration of your state machine, the edge cases are more visible to you. So I asked myself, and also, yeah, I 1 month ago, basically, I implemented the first feature in my company's project with Xstate. It's a very simple functionality, but it's a functionality that has given some issues, some bugs. So you have 2 routes with 3 panels which are open, closed, and half open based on different conditions. And as I said, we had a lot of bugs with this functionality, and the business logic right now is spread in 5 different components with some if and else statements. And not only these 5 components, there are more files about this functionality for Redux. So now, after this implementation with Xstate, we have a common source of truth, which is the configuration of the state machine. And actually, I was really happy when I finished the implementation of this state machine. It was before leaving for my vacations. So I sent an email to my colleagues, and I expressed my happiness. I said that it's a very nice and different experience, and I would love to do it more in the future. And this is the reality. I really enjoyed the process of implementing something with Xstate. So some takeaway notes. Actually, as a takeaway note, I would like to express my dream I would like to say what would be the ideal development process for me in my ideal world. So in this ideal world, the business analyst is responsible to create the state machine to express the intended behavior, and then the developers can use the same state machine configuration for the implementation. The QA team can start implementing the end-to-end tests with test scenarios which are provided automatically from the state machine configuration, and there are some there is already a small library on Xstate and you can use it in order to create automatically some test scenarios based on your state machine configuration. So what you can have is a common source of truth for the requirements, for the documentation, for the testing, and for the development. and as I said, this is the ideal world for me. But I think that right now you have the tools to work like this. And I hope in the future I will be able to work like this. And I hope the same for you. Thanks a lot.
Oh, great talk, Stefanos. I really like, by the way, the artwork you did. Did you make all the visuals yourself?
That's all right. That's all right. There's no shame in that.
Liked it.
Looked really nice. Very good talk.
Yeah.
Very educating, I'd say. Very nice introduction to Xstate. I've never heard of it, honestly. Yeah, awesome. Thank you so much.
We got some questions, and Iris, do you want to first go ahead with your question? I can pop it on the screen. You can ask it yourself.
Yeah. Are there any Visual Studio Code or Chrome extensions that we can use to visualize Xstate states in an Angular application or in a web application in general?
Next question. I'm not quite sure. I think that they prepare something for Chrome, but I need to check again. And I think, but yeah, really soon they will have a new visualization tool for Xstate, I think next month. But I'm not sure about the Chrome extension.
Okay, thanks.
So somebody else is asking what's different with NG, and it should be NGXS if I'm correctly.
Yeah, it's state manager as well.
NGXS, as far as I know, is a state management library based on the Redux design pattern, but correct me if I'm wrong. I haven't worked with NGXS, but the main difference is that with NGRX and NGXS, for example, the main difference basically is that NGXS and NGRX, they don't guarantee you that you can be in one state, only in one state. And with Xstate, you get this, and not with Xstate, but with finite state machines, you get this thing that you know that at in a very specific moment, you can be only in one state. Yeah, I don't know if, yeah.
Okay.
I can add a
let me see.
recommendation to
There's
that.
another one.
If you have like
I think your audio, Sander, I think your audio is a little weird for a sec there.
Okay, is it better now?
Yeah. It looks like you're a robot, something
It's
like
very cracky. Hopefully we'll get back to that question.
that. Yeah, I think we got another one, but let me double check.
I would also like to add something on this.
Sure.
Yeah, that, for example, I'm also not sure about NGXS particularly, but generally with the Redux design pattern, what you have is a global state. But in Xstate, they promote the actor model pattern. So where you don't have a global state, but you have some actors with a local state. So this is another difference with the Redux design pattern. Yeah.
Okay. And I think Alex also asked, I think it's in one of your slides. Let me pop it up. He said in one of your slides, could it have been accomplished with a single service that was encapsulated that business logic? And I think it was during one of your slides this question came up.
Yes, it could be, but of course, I assume that you could have, instead of the configuration for your state machine, you could have some if and else if statements. But yes, of course, you could use just a service instead of 5 components, as I said. Yeah.
Yeah, I guess it was during your example in your own experience. And I think the main difference, but it's always, of course, it's down to subjective situations and scenarios. Like you might argue that having one big service encapsulating all that business logic is a little bit more difficult to extend, I guess, right? But it depends on the situation, always. Yeah.
Okay, I think that was were the questions, at least from our viewers at the moment. I don't know if anybody else has questions. I think, Sander, you had something mentioned, but maybe your audio's not yet correctly. We could try
I'm
it.
not sure. Yeah,
it's good.
Is it better now?
It's good. Don't touch it anymore.
Okay, yeah, what I wanted to add is that like a definitive state machine like Xstate will conserve all the side effects and everything, while something like NGRX or the other one only basically store the results and not the way how you come there.
Yeah.
So this it's a different way of working.
Yeah, it's a different approach, basically.
Yeah, it's a different approach.
Yeah. And
Okay.
also,
I mean, you can like and use. You know, I mean, I'm not sure if you can use both at the same time. That doesn't seem like a good idea. But like, depending on the team you're working with or the particular brand that you like, I mean, there's nothing wrong with either one of them.
No,
it's all down to subjective, what you like, what you prefer with.
They work a little bit different. Definitive state machines are just that. They can encapsulate a definitive state. Well, Redux and NGRX, by definition, have infinitive state.
yeah, exactly.
Okay. Anybody else with the panel got questions still? Still there? Okay, then we're going to wrap it up. Aris and Stefanos, thank you very much for joining us and giving these great talks. I really liked both of them. I love the Electron part. I'm going to play around with it. And I'm going to definitely check out Stefanos' Xstate part and where we can check it out. Thank you all for joining. Viewers, thank you. Subscribe on our channel so that you can see our next meetup in September. It will be a special one. I can already slightly give an announcement about it. We are figuring the topics and that kind of stuff, but it will be a special one. If you want to participate in the talk, just send us a message for one of the organizers. That's me, Sander, Björn, or Stefan, or send us a DM on Twitter, and we'll contact with you to get you up and running here. Thank you all, and see you soon.
Thank you.
Good one. Bye-bye.
Bye.